Okay, good evening everyone.
Yes, sir.
Again, we are meeting here for discussing about the case study in our subject optical communication. So, right now we are discussing in our class about the optical communication, that structures and acceptance angle, numerical aperture ways. And this is here we are assembled here for discussing about the case studies. The case studies here, though we have several advantages in an optical communication, we still facing some challenges, especially in industries. Like deployment of optical fiber for long distance communication is quite practically it's impossible, right? So to overcome those issues, so we have to list out what are the major issues when we are deploying, implementing the long distance communication, especially in optical fiber, and we have to know give the appropriate solution so that that can be communicated to the appropriate industry, which we had already we made some MOE companies, right? We can give the solution as a consultancy partner. We can give the solution for this kind of a problem. So let us discuss, and we can have each and every one of your point, and we shall conclude the session. Okay, you can start.
Uh, Good evening, all. Today we are going to see a case study on optical communication. So in that we focusing on many challenges and logistics challenges and many maintenance, etc. So first of all, what optical communication means, so it uses an light signals to transmit a data from one object to another object through cables like wired cables or wireless, etc. Then it contains a large number of distance when coming to very large distance. There are many problems faced by the users, so like maintenance cost and logistics management, time complexity management, and long distance frequency distraction. These kind of challenges that we are facing. So for that we can discuss some solution based on solution and real time applications. So want to
I'm going to explain about the solution part to overcome the cost and installation cost and logistics of optical communication. To address these challenges, different strategies are used both technically and financially. In technical part, the first step is route optimization to find the shortest and safest path to reduce the length of the fiber. Then high durable cables are used to avoid the frequent repairs of the cable wires. Then in financial, private and public partners helps to reduce the cost burden. Then shared infrastructure, multi-service partners are use the same optical fibers to reduce the cost.
And next I am going to explain with the real-time project. The great example is CME Weeks is an undersea cable project in which the cable is 19,000 kilometer long. They used multiple telecom companies to integrate with that, and also uses router, as Alamu said, router optimization, shared infrastructure, and financial cooperation with the companies leads to these multiple projects.
Yeah, okay. So from your discussion, so the few takeaways are, as she said, Anamela said, finding the best route, right? So if we find the best route from the end-to-end communication, we can reduce the installation cost effectively. That is a very important thing, because this is the major reason, major issue which is facing by the many industries. So this is the one of the very point, and also when we are implementing, right, so many external factors, right, because of this environmental disasters, natural calamities, right, and also those things, it is unavoidable one, but we can have some IoT architecture to monitor the changes of the weather conditions and everything. We can have a good proper installation throughout the some tension, right, some duration. So this is also one of important thing, right? And so though we are we are focusing on this, as we already discussed, we have some trade-offs, right? We have to ignore some drawbacks when we are doing some some improvements. default by default some minimal number of drawbacks also we will be facing, that we cannot do anything, right? But only thing we have to concentrate, only thing we have to focus is how much advantage is there in our innovation. That is the very very important thing. If our innovation gives the 75% of advantage, remaining 25 is obviously if it is a drawback, that can be ignored, right? But our innovation gives only 10% of usefulness, right? And remaining 90% it is not useful for us, means that we can drop, right? So this is the thing. So thanks for the discussion. We can share this your ideas to our partner MOU industries, so that they can be benefited, right? Thank you. Thanks for the discussion.